So let's talk about the material jetting process. Material jetting process is an inkjet-based photopolymerization process. It's similar to the stereolithography we talked about in the previous lectures. But the difference is there's no vat or tank for the photopolymer. Instead, the photopolymer is selectively printed to a layer by the inkjet printing head. And then a UV flash lamp will cure the entire printed area such that you have a solid layer. Here shows the illustration figures of a photopolymer, a inkjet-based material jetting process systems. And so basically, if we talk about the one of the main system, which is the Stratasys PolyJet process. There are 4 inkjet printing head, and it scans back and forth, jetting the photopolymer onto the platform. It has 8 different colors: the cyan, yellow, magenta, black, white, and clear color, and 2 different support materials. Then the UV light cures the photopolymer after the after material is jetted on the platform, as there's no laser involved in this process. So I would say the best part of this process is it's really easier to print the multi-material or multi-color during the printing process. So let's look at this video. Here shows a video about a Stratasys J750 machine. We have the same one at the Imprint Center. As you can see here, it travels back and forth. The liquid polymer, photopolymer material is jet on the platform, and then the UV lamp cure it. So you can see there are 2 light sources, 2 lamps on the 2 sides. So the bidirectional printing and curing could be achieved. Also, another big company, 3D System, it has its own product lines, which is called a ProJet series. So the process is very similar. Plus, the only difference will be the color, right? It has different color, different types of color. So if we take the Stratasys PolyJet process as an example, because pretty much they're similar to each other, and we can look at what is the working flow for a PolyJet printing process. So first of all, the 3D model is sliced, right, to different layers, and then there will be a jetting and a leveling process for the layer, and then the UV light would UV lamp would cure the jetted photopolymer liquid, and then one layer could be obtained. Then it goes back to the jetting stage and repeat this layer by layer. Then you will have a whole solid model printed. So here shows a figure about how the liquid droplet comes from this nozzle. So there are 192 nozzles per channel, and there are 2 channels per head. Also, the diameter for the nozzle is 40 microns, which is very small. As you can see here, it shows the procedure of a droplet coming out from a nozzle. So from the leftmost, there's nothing, and then a droplet coming out, and it goes further and further. After a few moments, it leaves the nozzle. So you can see, because of gravity, it's something like this. It is stretched out, but after it hit on the platform, and due to the surface tension, it will bounce back to a spherical shape. Um, and let's look at some other details. Also, there are different modes for the PolyJet printer. The high-speed ones, high-quality ones, and high mix mode. So as you can see here, shows a illustration of the nozzles, and these are the nozzles, right? Uh, and the gap between each of the dot is 8 to 100 microns. As you can see, there's a spacing between each of the dot, and in the y-axis, and it travels in the x-axis. So then the question is, if we have a printing head, has a having the 65 millimeter as the width, and there are 192 nozzles along this width. Then what is the y-axis drop spacing on the head? So it's very easy to compute because you have the total y width and you have the number of nozzles. Just divide the total length by the number of nozzles, and you have the gap. Here I use 191 because for 192 nozzle, actually the spacing will be 191. So you have the total number minus 1, and then you have the spacing. Actually, if you use 192, it's also fine. I mean, it's just a small amount of difference. Another thing is, does the drop spacing in the x-axis direction have the equal drop spacing in the y? Actually, they are different. The answer is no, because in the x-axis, basically this printing head moves from this side to this side. Let's see, and during this motion, the droplet will come out from all these dots in a certain frequency. If we specify the moving velocity of this printing head as speed v, and the frequency of the droplet coming out of the dot, we put it as f, then both the spacing in the x-axis will be determined by these two parameters, and it has nothing to do with the with this y-axis, the spacing in the y-axis. And here shows a illustration of the leveling. You can see here we have leveling rollers such that it will make the layer a precise plane. And here shows the two UV lights, right? You have two lamp on the two sides, and such that no matter it travels from left to right or from right to left, after the liquid material is jetted on the platform, there will be a UV light curing afterwards. Also, for the layering, basically it will move from layer to layer in the height direction, which is the z-axis, and the layer thickness usually ranges from 16 micron to 30 micron, depends on the printing mode. But no matter which mode you chose, you can see even 30 micron is a pretty small number. That means the smoothness of the printed part will be in general better than other printing process. So after printing, I mean during the printing, if there are some facets on the part facing downwards, see these these facets, then you need to have a support material to support these features. And the support material would be washed away or dissolved in in some solutions. As you can see here, the resolution and accuracy for this PolyJet process is pretty good. It has a resolution 600 by 600 by 1600. Basically, 600 drops per inch in both x and y axis, and 1060 drops per inch in the z axis. And you can see the accuracy. Basically, it is between 0.001 to 0.003 inch for features less than 2 inches. For relatively larger features, the accuracy will be positive, negative 0.008. But still, it's pretty good compared to other printing process. Here shows you the different parameters of the different, different layer thickness and also the material used for different printing mode. And as you can see here, for the high speed and high mix one, it could achieve the 28 micron layer thickness. For the high quality one, you have the half of the layer thickness compared to the two other modes. So with smaller layer thickness, you will have a smoother surface. And as you can see here, it shows a much better step effect compared to this high speed with larger layer thickness. So as you can see here, we have a carbonate, and so basically you could just insert this cartridge into the carbonate. Here it shows only one side of this carbonate, and there are 8 for this side, and there will be another 8 for the other side, and in total there are 16 cartridges for this printer, and each of the cartridge would cost $550. So it's a very expensive machine and material to use. So as I mentioned, the best part of the PolyJet process is it enables the printing of multi-material and multi-colors. That means on the same part, you could have some area, some region has a very rigid material, and some regions have flexible material. And also, you could have different colors on the same parts. And here shows you a different the different materials. You could have rigid material or flexible ones. Also, some biodegradable materials for the medical applications. And if you look at the name of the material, if it starts with the vero, that means it's a rigid material. And if it starts with the tango, that's the flexible material. Also, for different different printing material, you have different support material associated as well. So basically there's a concept called the digital material. So the digital material are composite material, consists of 2 or 3 base model material, and they are integrated in a specific concentration and structures. So here shows a perfect example of this digital material. Basically, you have a rigid part, magenta color for this surface, and you have tango one. I think this is the vein of a heart, and you have a tango one for these muscles, and another rigid, two rigid material for 2 other different parts. And there are softwares associated with the printer such that you could specify the different colors and different materials. So here there are some so-called the color map, and you could and also here shows the interface of the software for the PolyJet. And I'm sorry. Basically, you could specify the different colors using this interface, and it tells you how to achieve one specific color by combining the different CMY key and other colors together. Also, there are color palette as well. As long as you specify the different the basic colors, it will tells you what colors could be achieved by looking at this palette. So for the color printing, if you look at this figure, so basically it's a chess part, and for this surface, basically we just chop off the part and see what it looked like interior. So you can see for the internal part, it is a plain white color, and that means actually for the part only the surface is colored. Therefore, when you design a model, you have to consider the thickness. If the thickness of the model is less than 3 millimeter, then there will be no core materials, right? So here shows all the different examples using the PolyJet printing. Even some clear or transparent part could be printed. So as I mentioned, after printing, you need to remove the support material. There are multiple different ways. You could use the water jet. Basically, it's a high pressure water based method, and you put it into this chamber, and the high pressure water will be used to remove the support. Or there are some chemical-based ones. You just put the part into these solutions, and these solutions will dissolve the support material. And there's more details about the support removal. If you have interest, you could look at it. Also, that's you could always paint the material. I mean the printed part. And first, you need to clean the model and sand it, and then do the filling, and then apply the primer. And after that, you could spray the colors and paint it to have a certain color. Here shows a very good part, basically painted by the people who print it. And this PolyJet process, systems are widely used in the movie industry because it can achieve really good shape, surface details, and that is the desired properties they want. Also, there are another process called the hydrographics. So if you do not, you haven't heard about this process, let me give you a little explanation. So you have a tank of liquid, probably the water, and you have a layer of, let's see, that's the layer of the water. And basically, then you could put the color layer onto this layer of water, and then you have your part deep into this tank. And when this part touches the color layer, the color layer will attach to the part, and then you just lift the part quickly, and after that you will have something like this. The color will attach to the color or texture will attach to the part, the plain part. So that's the basic concept of the hydrographics. You could Google it, Google this keywords and find more details about the process. So also you could glue the different parts together to form a larger ones, just like the one shown here. And in order to glue the part tightly, probably you want to design some features like this kind of ductile features, right? Oh. And then you will have two parts glued together, right? Then you need a little clearance between the two mating part, such that when the glue is applied in between of the two, it won't come out. It won't uh, spread out. If there's no clearance, if when you apply the glue, it will come out from the joining regions. And here shows some details about how you design the ductile joining part, how you specify the clearance. You could look at it in details. Also, the photo bleaching process will will eliminate the effect of the the color fading. Basically, you could either apply a table lamps or this better, a better process which requires a chamfer, illumination chamfer. So basically, you just put the part under or inside the chamber or under a lamp, and after a few times of exposure to the light, the part will become a better surface transparency or clearance. Let's look at here. So this one shows the part without any treatment. You can see it becomes a yellow color, and also there's one processed by the chamber and another one processed with the table lamp. And you can see the best result is achieved by the chambers. And if you have interest, you could definitely look into the detail about how you do the photo bleaching with the table lamps. So another very important principle for position your part is don't build small parts next to the tall one. So as you can see here, all the parts are put on the same platform and built at the same time. And you have these clear but small part, these ones. And you have a very tall part showing here, see? But you can see for the small part, the color different. The one near this tall part becomes a yellow, more yellow than the one far from the part. And the reason is, so basically because these parts are smaller, are shorter. So after these are built up, the printing head will focus in this region, right? To build the top part layer by layer, and it will travel back and forth in this region. At same times, the UV exposure, UV light will further cure these part near this tall one, and such that will make the part become more yellow. So again, if that's the case, don't build a small part next to the tall one. So another process is the polishing. As you can see here, if you print a lens, you could always polish it to make a better clarities. Also, there are different ways doing the polishing, and you could check it. And you could see that a significant difference of the parts before and after the polishing. Of course, you could also do the dyeing by applying the dye after the printing. You could just easily do it. So there's another process, the lacquering. Basically, you could just purchase a lacquer and apply the part, use them, and some of the details you could look at this slides. Also, in order to improve the heat resistance, there are the thermal treatments as well. So basically, you could just increase the heat deflection temperature, which would make the part a better heat resistance. Also, the part could be coated with metal as well, and some commonly used ones are nickel, copper, or chrome. Because the part is in solid, is a whole solid, it's definitely possible to drill holes or tap some threads on the part. And of course, the brittle ones will be challenged to further process, use the drilling and the tapping.